Voyager 1. Humanity's deepest journey into the cosmos. In the quiet stillness of space, beyond the planets, beyond the sun's reach, there floats a tiny machine, alone and determined. Its name is Voyager 1. And it is the farthest any human creation has ever traveled. Launched in 1977, this spacecraft began its journey when disco ruled the airwaves, the internet didn't exist, and mobile phones were still science fiction. Yet more than 4 decades later, Voyager 1 is still alive, still sending data back to Earth, and still pushing the edge of the known universe. What was once a mission of a few years has become a timeless odyssey, a living monument to human curiosity, endurance, and the hunger to explore the unknown. A mission born from alignment. The story of Voyager begins with a rare celestial opportunity. In the late 1970s, the 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, would briefly align in space. This perfect formation happens just once every 176 years. A visionary engineer named Gary Flandreau at NASA's Jet Propulsion Laboratory recognized this opportunity. He realized that a spacecraft could use gravity assist, a method of using a planet's gravity to gain speed, to travel from one giant planet to the next. With this technique, a journey that would normally take 30 years could be completed in just 12. NASA responded quickly. In just a few years, they built and launched 2 nearly identical spacecraft, Voyager 1 and Voyager 2, just 15 days apart, in the summer of 1977. Their original goal was simple but ambitious: study the outer planets. But what followed was far beyond what anyone could have imagined. Rewriting the solar system, Voyager 1 made history as it flew past Jupiter in 1979 and Saturn in 1980, capturing the most detailed images ever taken of these gas giants and their mysterious moons. It discovered volcanic eruptions on Io, the first active volcanoes seen beyond Earth. It revealed the icy crust of Europa, suggesting a hidden ocean beneath its surface. These were no longer just distant rocks, they were worlds with complex geology, atmospheres, and perhaps, even conditions for life. Meanwhile, Voyager 2, its twin, went on to make its own historic path, becoming the only spacecraft ever to visit Uranus in 1986 and Neptune in 1989. It revealed magnetic fields, dark storms, and even new moons, reshaping our view of the outer solar system. And all of this was achieved using technology from the 1970s. The Voyagers are about the size of a Volkswagen Beetle, equipped with computers holding just 69 kilobytes of memory, far less than a modern calculator. Their data is recorded on magnetic tape and sent back to Earth through 23-watt transmitters, about the power of a fridge light bulb. Yet, even now, decades later, they remain in contact with Earth, using massive radio antennas from the Deep Space Network. Their signals, traveling at the speed of light, take over 22 hours to reach us. Despite the vast distances, Voyager 1 still speaks. A whisper from the edge of the solar system. Crossing into interstellar space. But perhaps Voyager's most important moment came years after its planetary mission ended. As it drifted farther from the Sun, Voyager 1 approached the mysterious edge of our solar system, the heliopause. This is the invisible frontier where the Sun's influence ends and interstellar space begins. Here, the solar wind, charged particles from our Sun, gives way to the ancient pressure of the galactic winds and cosmic rays that drift between the stars. For decades, scientists expected the heliopause to be a sudden boundary. A sharp shift in particle flow, temperature, and magnetic fields. But Voyager 1 surprised everyone. Voyager 1, humanity's silent ambassador to the stars. As Voyager 1 ventured beyond the orbit of Neptune, it began approaching the outermost edge of our solar system, a place where the Sun's influence fades into the vast unknown. This invisible boundary, known as the heliopause, marks the end of the Sun's magnetic field and the solar wind's reach. It's the final curtain before entering true interstellar space. But crossing it wasn't dramatic. There was no sudden flash, no bold line that marked the edge. Instead, the data Voyager sent back was nuanced, subtle, and confusing. The magnetic field, which scientists had expected to reverse direction, remained surprisingly consistent. The levels of charged particles, solar radiation, gradually decreased, while galactic cosmic rays, high-energy particles from outside our solar system, began to rise. For a time, even NASA wasn't certain. Had Voyager 1 truly crossed the threshold? August 25, 2012, a quiet revolution, then came the confirmation. On this date, humanity's farthest probe officially became the first human-made object to enter interstellar space. It was no longer orbiting our star. It had broken free from the sun's protective bubble and entered the cosmic sea between the stars, an ancient, vast realm sculpted by the deaths of stars and the birth of galaxies. What lies beyond? Not silence, but song. We used to imagine interstellar space as cold, dead, and empty. Voyager 1 proved us wrong. Its instruments recorded plasma wave oscillations, subtle vibrations traveling through clouds of charged gas. These waves told scientists that even in the black void between stars, there is activity. A quiet hum of cosmic energy resonates across the dark, evidence that interstellar space is not still, but alive. The edge of our solar system, once thought to be a distinct boundary, is more like a blurred shoreline where two great oceans, solar and galactic, meet and merge. The heliopause is not a wall but a messy, tangled interface of overlapping forces. It revealed that our understanding of space must evolve, because the cosmos is far more dynamic than we imagined. The journey continues. Voyager 1 is still moving, at nearly 17 kilometers per second, fast enough to circle Earth in under 90 minutes. It's now over 24 billion kilometers, 15 billion miles, from home, farther than any spacecraft in history. Its systems are fragile. It was launched in 1977, with computers less powerful than a modern calculator. Its camera is turned off. Most of its instruments have been shut down to conserve power. And yet, it endures. It runs on a radioisotope thermoelectric generator, RTG, converting the heat of decaying plutonium into electricity. But this energy is fading. By the early 2030s, Voyager 1 will go dark. One by one, its systems will shut down. The signals will grow faint, then disappear. But the spacecraft itself will not be lost. It will continue to drift, silently, on a path that could last billions of years. A golden message to the cosmos. Voyager 1 carries something extraordinary. A golden record, a time capsule from Earth. Etched into its surface are greetings in 55 languages, sounds of our planet, birdsong, thunder, a kiss, a heartbeat, music from many cultures, Beethoven, Bach, Blind Willie Johnson, images of life on Earth, mathematical equations, cities, families, DNA, nature. It is a message written not for aliens, but for the future. A whisper to anyone, or anything, that might find it. We are here. We existed. We reached for the stars. In the quiet depths of space, Voyager is still carrying our story. Voyager's legacy, more than a spacecraft, Voyager is a symbol. It represents curiosity, endurance, and the boundless reach of human ambition. It reminds us that great discoveries don't always require perfect tools. They require vision, courage, and the will to explore. Launched with 1970s technology, using tape recorders and 8-track memory, it still outperformed expectations. It unveiled the moons of Jupiter and Saturn, discovered active volcanoes on Io, ice geysers on Enceladus, and strange hexagonal storms at Saturn's poles. And when it turned back to capture the famous pale blue dot photo, Earth as a tiny speck in the vastness, it gave us a new way to see ourselves. What comes next? Voyager 1 is a pioneer, but it won't be the last. New missions, powered by ion engines, laser sails, and quantum navigation, are already on the drawing board. Concepts like Breakthrough Starshot envision tiny spacecraft reaching nearby stars within a human lifetime. Should we build a Voyager 2.0, a modern interstellar probe? Should we send a new golden record, updated with humanity's progress, culture, and questions? That choice is ours. But Voyager reminds us that space isn't just a place, it's a mirror. A canvas where we project our dreams, our science, and our humanity. The universe is still listening even now, deep in the black silence. Voyager 1 is sending signals back to Earth, faint, crackling whispers received by giant antennas. Across this immense distance, it continues to report back, like a lone lighthouse flickering across a cosmic sea. One day, its voice will fall silent. But its journey